Raisner is an Aquaponics Cannabis guru. I started doing aquaponics about 8 or 9 years ago. I was running veggies, growing tomatoes and super hot peppers and microgreens in Minneapolis area. And I first ran into him online. He was working for the Aquaponic source. And he started spitting out all these cannabis videos. And I was like, oh, this dude's dope. And then he started putting out the Ponics podcast, which he's now at what episode?
It'll be like 130 this week, I think.
130. And it's really good stuff. So many good speakers have been on deep into the science of aquaponics, how to figure out all the nutrient cycling, and I'll let him go. But it's been really cool getting to know Steve, and just kind of take a deep breath. It'll be another hour and a half. We're gonna go hard for that, and then we'll take a good solid dinner break, get smoked up, and come back this evening for the Q&A, which will be fun. We'll have Josh and Kelly up here, Steve, Suzanne's gonna come back. She's out running around taking photos of bugs, but she'll be back for tonight. Leighton, myself, Wendy will stand on, and so it'll be a really good time. And it's like Leighton was saying earlier, it's really good I enjoy like when speakers have conflict of opinion, because then they can hash it out, and it's in a loving way. It can be really productive, and we can all learn from some of this stuff, and that's happened a bit today. And I hold a lot of value in it. So thanks for the good questions, and thanks for being open to to hearing and trying to dig out the information, rather than slanging mud. So without further ado, Stephen Raisner.
Sorry about that. All right. Break myself here. First I want to introduce myself. My name is Stephen Raisner. I own a company called Ponics, which is based pretty much all over the place these days. And I specialize in aquaponic cannabis production. So we talked about, this morning we got to hear all about the soil food web. Now we're going to talk about the aquatic food web. All right. So a little bit about my background. I used to work in the aquarium industry. That's kind of where I got my chemistry, or feet met with chemistry. Used to do reef tanks and all different types of planted aquariums. And in those kind of realms, we think of everything with individual ppm. So we need to know what's the strontium ppm level, the calcium ppm level, the exact alkalinity. And in the hydro world, everybody likes to talk about total ppms. What's the EC? Well, in aquaponics, we have so much of the loose biologicals. EC is almost useless because there's so much like noise in that. You can't. It's not just the mineral reading. So there's a lot of challenges that we've had to work out. And I ended up working at the Aquaponic source after working in the cannabis industry. The floods happened. For those of you that were in Colorado at the time, and the facility I was working at got damaged. So sorry, a little out of breath. One too many dabs before I got on the stage. So after that, I ended up working at the Aquaponic source. And when I was 2 weeks after starting there, they had a company meeting, and Sylvia was like, Sylvia's the owner at the time. She's like, does anybody here know how to grow cannabis? And I was like, I thought maybe they were trying to set me up because I just started there or something. Like, that's me, that new guy. So I just played stupid. And then she's like, well, we need to find someone, reach out to it. Like, if anyone can get a good email. And I was like, oh, wait a minute, you're actually serious. So on the East Coast, going back to what I was talking about, the aquarium stuff, a lot of East Coast pet stores have a back room. Or it's a good way to clean your money if you're having a big grow up or stuff like that. So half the places I worked at allegedly on the East Coast had some kind of interesting things going on the side, be it exotic animals they were bringing in, or cannabis, or all kinds of other stuff. And that's where I was first learning to grow cannabis. And way back in the day, there was a gentleman named Breeder Steve who actually had some stuff on putting fish waste on some hydrogen pots, which was basically really similar to what we do now with dual root zones. This is way back in 1997. So if you guys are looking to like what's the origin of some of this aquaponic stuff, it actually goes back to Breeder Steve, which is super awesome. A lot of you guys know who he is these days. He runs the, I can't remember the name of the company down in Colombia, but that's 30,000 acres or something like that. But so I ended up working at the Aquaponic source when I was there. I ended up running their laboratory, their research and development. We had two 50 by 30 by 18 foot greenhouses that we could run all different kinds of experiments. We had raft beds, media beds, wicking beds, Dutch pots, all different kinds of stuff to see how can we grow cannabis in aquaponics. We did all kinds of tissue samples. We used to, give some kids a little cash on the side to go do tissue samples with us after hours at a couple of the local colleges because I couldn't get legal tissue samples on cannabis. I couldn't tell what my baselines needed to be. No one could tell me, hey, what's the nutrient ranges for aquaponics for cannabis? No one had done any research on it. So we were doing tissue samples and trying to match that against, a lot of the known soil documentation, so we could try to hit those levels and really match that production. And now we can even vastly exceed production of most soil stuff, especially in the same timeline. It's not even close. So these days I have my own company. I've worked in Jamaica, worked in Canada, currently doing a lot of work in Oklahoma. They seem to be all about aquaponics, which is really good. They have a really good climate for it. So you can, with aquaponics, you have a lot of different advantages. You use a lot less water, you use a lot less nutrients, and it's really a great way to maximize production in your system. So we're going to talk about the aquatic soil food web and how you can benefit that, and why you might want to consider using it as a portion of your farm plan. So what is aquaponics? Well, aquaponics is taking and mineralizing fish waste and allowing that fish waste to be broken down by various microbial chains and converted into bioavailable nutrients. Think of it like a syringe. Those microbes help inject those nutrients in so you can run them much lower levels. With aquaponics, we generally run a quarter or less of what you would with hydroponics and get better results. So traditionally you're told, in aquaponics you have nitrosoma, the ammonia gets broken down into nitrosoma, into nitrite, and then broken down again into nitrate. Well, that's really awesome for nitrogen, but that doesn't tell you anything about phosphorus or calcium or silica and all these other things, and no one ever talks about that in aquaponics. I never understood that because you have 20, 30, 40, 50 different chains going on, and they just only talk about the one because it's the one that they know from aquariums. And that always confused me coming into the, from the plant world. It just made no sense. So here's a typical aquaponic system. This is the base that we use from almost all of our flood and drain type with aquaponics. Is anyone who invented the bell siphon? No, Pythagoras. Pythagoras invented what was called the greed cup, and it had a bell siphon built into the center of it, and if you overfilled it with too much booze, it would dump it all over the front of you. So it was a pretty cool little trick. So anyways, how the bell siphons work and the advantages of the bell siphons is that when the water goes up to the top of that bevel there, it starts to go through. Well, if that bell is on top of that, what it allows it to do is it creates a vacuum that drafts the water down. And what that allows me to do is run the pumps continuously, and that allows us to get a good diaphragm action going in the root system. It means they get much, much higher gas exchange, and when we combine it with dual root zone pots, we get a really accelerated diaphragm action, giving us incredible growth rates on our plants. And we'll show some examples of that here. So the different components of an aquaponic system, you have your media, which is your home for all your microbial diversity. That would be like your soil. That's the place for these microbes to colonize and build upon, and have a place to live. You got your mineralization tanks down there. That's where we're going to put our fish waste, and we're going to brew it, similar to compost tea. And what that is going to allow us to do is really unlock the full value of those nutrients from that fish waste. If we had just simply allowed it to be in the system, it can build up over time into anaerobic layers and cause all kinds of issues with the pH, among other issues. It can breed pathogens that are unwanted and all kinds of other things. But by separating it and putting it in an offline brewer and brewing it for 3 to 5 days or 14 days, we can really heavily unlock that. We can take in all the microbial biodiversity that you guys have from compost, throw a little compost in there. You can throw your mammoth pea in there. You can throw whatever your chosen microbials that you guys have. Your IMO can go in there, and they're going to unlock all of those goodies in the fish waste the same way that they would unlock things from the soil or from manure or other things. And this allows you, how you can maximize and really get down to only 5 to 10% supplementation on an aquaponic system at all, as far as trying to balance the whole thing out. You got your fish tanks. They come in all different shapes and sizes. If you're looking for big tanks and stuff like that, there's 2 companies really to kind of handle most of that. There's one company called Polytank and another company called Polymart. Sorry, Polymart and Polytank. And both of them will deliver stuff. They make everything from little igloos for cows all the way down to small filter tanks and everything in between. Then you got your grow beds. Now grow beds, generally you want to have nothing bigger than a 12 by 4. If you're going to do 1-inch flood and drain plumbing with a bell siphon, when you get larger than a 12 by 4, you start to have problems with trying to balance the flow rates out. And it can be quite the pain in the ass, so that's literally the largest I would go for. You can set a row. I know I'm currently working on a big row in Oklahoma. We have 44-foot rows, and it's 3 things of 12 and 1 row of 8. So it makes it nice and easy when you're doing it. You get your roll of Durascrim, you roll that down, pop that up, build your wooden frames, you're good to go. So then you have your sump tanks. Now your sump tanks, you want to make sure you have the bed volume of all of your media beds minus 50%, because you're going to displace it with media and the plants and everything in there, minus 50%. So that's how much you're going to need for the sump, plus 30% to make sure that it never runs dry. You want that pump to have 20 to 30% wiggle room, so you don't have to top it off all the time. Otherwise, it gets really annoying to top it off. All right, so here's a small system. This is just a tough tip. I know anybody here that grows a lot of weed knows what those bottom containers are, because we use those for curing. And there's a concrete mixing tray. This whole thing costs about $40 to build at Home Depot, and this is just a constant flood with a little flood and drain kit, like you get, the timer. Super simple. We grew all kinds of veggies. I used to teach a little workshop on people on home aquaponics and apartment aquaponics, and especially for education. These are cheap. Again, under $50. You can build a small home system if you want to get your feet wet. Throw some goldfish in the bottom, and you're off to the races. All right, so this is a bigger system. This is one of the systems I used to design when I worked at the Aquaponic source. We used to build these based on the hydrofarm kits. A lot of the cannabis guys and a lot of the other people wanted set bed sizes for whatever reason, so this is what we used to do. You could ship them all on pallets and everything. It made it kind of nice. But just an example, you can see the, one of these is a laser, right? There we go. Your fish tank here. You got sumps. These are 130-gallon sumps with 125-gallon beds on top. I'm sorry, those are 100-gallon beds. Those are 3x3s. Anyways, and those are 3x3x14. And then here's an example we did in Jamaica. So this is a little bit different design. So in Jamaica, we wanted to use a lot less water. So in order to use the minimal amount of water possible, because there's 2 reasons for that. 1, they don't have that much water. And 2, if I need to dose something like DTPA iron or a chelated iron, I need to be able to do so without with the minimal volume possible, because it's expensive to import it to Jamaica. So I want to use the minimum of water volume so that I get the least amount of oxidation. So what happens is we only have the 2 sumps here and the fish tank and a little bit of filtration. So this is recirculating, and then this runs on an indexing valve. So it works kind of like a timer. It'll flood this bed for 15 minutes, then this one, then this one, then this one. And this just works on a rotation, and then same as this one here. And this allows us to use the minimal amount of water possible. We can actually run this whole system less than 3,000 gallons, even though these beds are 96 feet long. So you can really maximize, the efficiency of what you're doing, on a very small volume of water. We also use, the only water we lose, because everything has a little bit of gravel and everything, is to what the plants use. And the other nice thing is, and we'll dig a couple little holes out in the gravel where the plants sit, and you have the bees coming in and drinking from it. So it gives them a place to come and drink. Especially when I was down in San Diego and out in the desert, it was really awesome. You have bees coming in from all over, and they totally ignore you. You have this huge swarm of bees around you, just all drinking. So this is this is a commercial design we're doing in Oklahoma. So we have our 2 production greenhouses here. You have your fish tank and filtration up here. If I want to bring a guest in or something, there's a little wall. It's a little out of proportion, with the final design. But there's a little wall here, a screened off wall, so that the people can't actually touch anything. And you can bring the public in or a guest if you wanted to impress somebody and show them the fish tanks and in the room without breaking any rules. They're still physically separated, so you're still allowed to do that in a lot of states. And then you have your changing room, because anytime you're in a bigger grow, everyone needs to be changing their clothes. If they aren't, they need to be screamed at. And then you got your moms over here, you got your younger plants here, your fresh cuts over here. It makes for a nice workflow. No one can get through without getting changed, and works out pretty good. Here's an example of a similar design I did or helped out with. So this is these guys are down in Pueblo. These guys eat hemp. I was just there on Monday and Tuesday. These guys actually do hemp. So this is a really good example of a hemp, very similar design to the one that I just showed you. This actually was originally designed by Nelson and Page. Don't buy their systems. They're horrible for cannabis. We fixed them up. It's a lot, changed up significantly from the original way it was set up. But they do sell a lot of people systems for cannabis, and they should not. But as you can see, they're nice looking plants. You can check them out on Instagram. They got a really nice Insta. So here's an example of the different nutrients. You can see this: the fish and the plants and the microbes aren't necessarily using the same nutrients. This is a study done back in 2005 on aquaponics specifically. So why would you want to grow in aquaponics? Well, it typically uses around 18% of the water of a normal system. And we also use 15 to 30% of supplemental nutrients per run. Granted, most of the strains were sitting around 11 to 15% now. Every once in a while we'll get a real finicky strain that really wants to feed heavy, that's used to hydro stuff. But remember, how long have we been breeding plants to overfeed? For a long time. They're basically like flog raw plants. We were talking to this at dinner last night. These plants are so used to being overfed that some strains really kind of freak out when you give them all the nice organic stuff, kind of like some people do, So you have a bunch of extra revenue streams as well. So you have fish waste, compost tea, worms, ferments, all the things you're generating from your farm or for your farm are added revenue streams. On top of that, we have this huge thermal mass, which we'll get to in climate control, that can dramatically reduce our costs, meaning on average we're running 40% of the costs through an average year compared to a normal soil grow in a greenhouse in a northern climate. Especially when it comes to climate control, it's almost like cheating. And we'll get to that here a little later in the deck. So it also improves flavor and terpene content. And almost everything, terpene especially, total terpenes, we've increased every single time against the soil control on aquaponics. And then also CBD production, all of them except for one strain, we've seen a noticeable increase in CBD production as well. And we're attributing that to the increase in biodiversity, which we'll get to in a couple of slides. So aquaponics increases terpenes, in particular, as well as CBD and THCV. We've done some really cool work with a couple of different cultivars, and really had some incredible results with THCV. Some of the highest numbers I've seen anywhere. I've showed a couple of people some of the test results here, some of the crazier stuff that I've done. If anyone wants to see that afterwards, I can show you that, some of the SC lab stuff from California. But also did a bunch of stuff at Kentucky State. They're working on formally documenting in a peer-reviewed form through the university how CBD increases THC level or CBD levels in hemp. They can't do cannabis yet, but they can absolutely do stuff on aquaponics. They actually did a really wonderful study I'm going to talk about in a couple of slides on lactobacillus, and made the fish grow 15% faster along with the plants. So it's really cool stuff. It also eliminated non-human pathogenic E. coli from the system, so really tricked out. So working with multiple different farms, I have a bunch of different awesome data. A lot of the stuff I'm NDA'd on, some of the stuff I'm not. I'm working, thankfully, with a bunch of guys this year in Oklahoma that are a lot more chill about sharing a bunch of stuff, so I'll have a lot more videos this year than I have had in the last year or two. So, what is the roles of fish? So fish produce ammonia and CO2. They produce ammonia both through their waste and through their respiration. And this gets converted by microbes, either directly used by the plants or converted by microbes into nitrate in order to create plant food. Well, it also provides other minerals as well. It will not provide all your iron, it will not provide all your calcium, it will not provide any silica. If you put enough potassium through a fish to fully flower a plant, you will give them a heart attack. It kills them. You can't do it. There's just limits on things. So hopefully there's some really cool microbial products coming out later this year that I had a chance to be privy to that are going to increase some of the potassium and some of the other cool stuff in very unique organic chains. It's going to be interesting to see how well that works with aquaponics. With Mammoth P, actually did way before they even started off. Mammoth P gave us a whole 5-gallon bucket of the stuff. I was working at an aquaponics source, and we actually put a 1-gallon in a 10-gallon aquarium with a bunch of goldfish, and they lived for 3 months. We just ended the experiment because clearly, 10% of the water being the product was in a lethal dose, and that's way more expensive than anyone ever would put in a multi-thousand-gallon system. So, it's pretty safe stuff. It's also nice, if there's runoff or whatever, you don't have to worry about that. Now you have to worry about with aquaponics. One of the other advantages to aquaponics as well, if you're here and you're looking to be an organic certified facility, if your soil, you need to wait for 4 years, you have to work that land to be organic. If I'm aquaponics, I can get aquaponics organic certified as long as I build it with the right materials within a year. So if that's your goal, you can do it a lot faster. It's a lot more paperwork though. And the feds in the United States still won't let you do it yet, but it's coming. So herbivorous fish also tend to produce a lot more phosphorus, and then carnivorous fish tend to produce a lot more nitrogen. The protein, the higher the protein in their diet, the more nitrogen they're going to have. So if you had a veg system, you're going to set that up to be more for carnivores, and you're going to set up a flowering system to be more for omnivores or herbivores, and you're going to get much better results in general. You're still going to get nitrogen out of them in the flower, herbivores, but you'll get less nitrogen. It'll be much more balanced. Yeah. So a bunch of different fish species that work well. So you got tilapia. Tilapia are great if you don't know what you're doing. Their plate price is horrible. They're like $2 to $4, maybe $5 for a fish. Not really worth your time. So one of the problems we've had in most states, and I haven't tried to work with someone in Michigan, so I can't, or anyone in the Midwest, so I can't speak on that behalf, but I know on the West Coast, we were having problems with the meat processing certification boards not touching anything that was cannabis related. They were terrified of working with cannabis because they were worried that something would happen to them because they were just uneducated on cannabis. And not knocking on them, but it terrified them because it was something they ever had to work with before. So we've had almost no one be able to get food processing. So we've been doing koi, butterfly koi in particular, because they have a pretty predictable increase and we can get them for $1.25 each, and then we can flip them for $20 to $80 a piece. It's way more than I'm ever going to get with a tilapia, and I can sell them for the same grow time. So it makes no sense. So koi, again, kind of your best bet, especially for a commercial producer if you're looking to start off. They have a really good resale price. They're really, really hard to kill. If your employee overdoses something, chances are it's going to survive. At least buy you some time so you can fix stuff. Pacu is another good one that grows real quickly, great for your flowering systems. Goldfish are really good. Plecostomuses, you can see this guy up here. Does anyone know what this is and how much they are? That's a zebra pleco. Those guys started around $200. You can breed these guys. A lot of the more exotic plecos, you can buy them cheap in bulk and raise them up and get $200 to $300 a piece for them wholesale. And it can be a great way to supplement. I know plecos love to feed on fan leaves. And I used to have a whole 300-gallon tank full of all different types of plecos, and I'd take all my fan leaves and they would just go nuts. It was like a piranha tank when you threw the fan leaves in. Perch, yellow perch are a really good one. They love that 68 to 72 degrees temperature we want for our reservoirs. So they're a real good one. If you were able to get a meat processing facility, they're probably going to be the best one in terms of plate price, to ease of raising, to feed ratio. They're really going to be one of your best, monetarily fish-wise. So Arapaima is another really good one. If you're raising stuff along with arowanas, in the Asian culture, especially Chinese and Japanese culture, they love their exotic red arowanas and arapaimas. They're extremely expensive, The aeroponics you do need to get permitted for by the feds, but it's not very hard as long as you don't have a bunch of felonies for smuggling animals in your past. And yeah, and when I was on the East Coast, we used to have people ask me, "Oh, well, I'm going to go to Florida. You're going to get the keys, and I want to bring some corals back." And we would joke and be like, "All right, well, your bag of coral, brick of cocaine, bag of coral, brick of cocaine." And they'd be like, "What's the cocaine for?" And it's like, well, the fish is automatic 10 years in jail. The coke you get off for 6 with good behavior. So you might as well bargain the coke because it's less jail time. And then at least pay for the gas for the trip. So those Aeroponics and arowanas both, arowanas, depending on the variety, can sell upwards of $20,000 a pop. The Aeroponics, again, they're in that same kind of $2,000 to $10,000 range, especially if you raise them out to adults, which takes 2 to 3 years. But if you're getting that kind of return, you will do 2 to 3 years. The biggest one I've personally seen was a little over 11 feet. Yeah, that was down in Peru though. And in the United States, the biggest one I've seen is about 9. Still big though. Like they'll injure you. Like I've seen people severely injured, broken orbital in Florida. My buddy was helping them move them over at a fish farm. Well, no, when they catch them in the nets to move them over to the breeding ponds, you just got basically punched in the face with the tail. But it's a 9-foot fish. Bluegill, they're a really good one. Bluegill are also good if you have a pond and you got lots of duckweed trying to get rid of it. Bluegill are a great way to have something that will eat it and get rid of that. Sunfish as well, they get pretty good plate price, they grow pretty quickly. Make sure if you do raise bluegill and panfish, you use lactobacillus ferment in their tank regularly, as they love to beat the crap out of each other, and the labs really helps reduce the infections when they tear each other's fins up a little bit. It really, really, really almost works like an antibiotic. You're seeing more and more people use it with both shrimp and fish as a kind of a way to prevent fish disease, especially with more aggressive fish that beat on each other a little bit. It really makes a big difference. There's a real big fish shrimp guide, which is a big whole video series on lactobacillus. And you don't have to actually, well, I'll talk about it in a minute. Shrimp and prawn. So shrimp and prawn I would not recommend for cannabis unless you're going to do a decoupled setup, which gets significantly more complicated and expensive. And then crayfish as well. And then for algae eaters, the Chinese hyphen algae sharks, they're really, really awesome because they'll tolerate the same temperature as a koi. So if you're going to run the system seasonally and bring the temperature down in the wintertime, you can throw them in there. And they're also, their favorite food is that filamentous hair algae. If you have a pond and you get that hair algae that jams up your filters and shit, they love it. It's literally their favorite food. So you get 1 or 2 of them, they'll wipe it all out of your pond. You'll have a little bit where it regrows, but they'll wipe out all the big clumps of it. Literally, it's their favorite food in the world. And that's been one of the only ways I've been able to treat hair algae when I used to work in the aquaculture industry before this. On big scales, reliably without using UV sterilizers or ionizers or some of the other stuff that can make some of the meat taste weird. And then tropical fish as well. Tropical fish you can totally do. And honestly, that would be the best, most monetizable way to do a farm would be to set up like a tropical aquarium, import type place or breeding facility, and then just take all the waste and turn it into cannabis food. The last thing I want to say with fish is there's a farm in California, and they do sturgeon, and the state pays for the sturgeon to be raised, and then they release them. There's a company that comes and takes all that fish waste and turns it into fertilizer for their cannabis company. But you could absolutely set that up for an aquaponics type facility where you're raising whatever local game fish is, they're trying to reintroduce or whatever, and get the state to pay for your cannabis fertilizer. Rather than fearing them, you can get them to foot the bill. So it's definitely something to think about, and reach out to your local DNR. And Department of Natural Resources, and find out if they have any outreach programs, because a lot of states have that because they're trying to reintroduce a lot of these rarer fish, and they'll happily give you fry and food and tell you what the parameters are. That's cool. Just grow your cannabis off of it. It's totally fine. So some of the other fish foods, some of my favorites: peas, broccoli, nori, romaine, and pineapple are great for veggie stuff. And then insects. So I'm a huge fan of dubia and hissing cockroaches. Dubia and hissing cockroaches are some of the best feeders for aquaponics because they raise, they have a really great fat to protein to calcium ratio. You can raise them by the thousands with no lid on the container as long as you have a 2-inch band of Vaseline on it, and they will not cross it. And then you just take all your scrap plants, anything that doesn't look right, anything that's getting a little moldy, you throw it in there, it'll be gone in 10 minutes. They're like a garbage disposal, especially when you have a few thousand of them. Literally, I used to take a trash bag, I put a trash bag in there and it'd be gone in 2 hours. It was insane. And it was just a 65-gallon tank. It wasn't even like a big tank. So, black soldier flies, they're another really good one. The resale value for them is really good too. 25 of black soldier fly larvae, and the pet trade sells between $6 and $8. You can raise them by the thousands easily off your fan leaves. So it can be another great, passive income even for soil farming. Crickets as well, they're okay. There's pelletized foods. I like Streeting and Optimal. Those are the two companies I recommend if you're looking for a bagged food, if you're doing either aquaculture or pond fish or aquaponics. And then frozen foods and garlic. Garlic is really good if you bring in exotic fish and you think they have a parasite, or if you have a fish that's not eating and it's being skittish. Garlic is like putting sugar on something and giving it to a 3-year-old. 98% of the time they're going to eat it. So it can be a great way to entice a sick fish, an injured fish, a newly introduced fish into eating. So the role of plants in aquaponics. So the plants absorb all the nitrates and other fish toxic nutrients and clean the water up for the fish. In aquaponics, you use about 70 to 90% less water, depending on the scale of your facility. If you do really large facilities, you have a little more open air. If you're doing stuff like out in the desert, you have a little bit more evaporation. But on average, depending on the way that your methodology of growing, depending on how you do your soil. Now with things like swales, we're probably closer to 30% above them, really responsible, no-till soil. We're definitely not 90% above it. I'll be the first person to admit that, but Jeff, comparing, traditional, most commercial production, we're, about 80 or 90% beyond them. So plants grow as much as 50% faster. We've had over 6 inches of growth per day in veg, sometimes even faster than that with the aquaponics. It's insane. And 3 new nodes. I'm not talking about just stretching nodes. I'm talking about 3 new nodes with the leaves opening. And we're going to show you some pictures of some of this stuff in a second here. So here's a picture of some of the designs we do for colder climates. This is actually in Niawak, Colorado. This is one of our R&D greenhouses. We did a 50 by 30 by 18 foot greenhouse in the Front Range of Colorado with 87 pounds of propane for a whole winter. So we'll talk about how we did that in a minute. So what's really cool is, here's the study that I'm about to talk about. So there was a study done by the USDA, and they looked at the biodiversity of aquaponic systems, of soil food networks, and of aquaculture systems. And what the goal was what are the key microbes we need if we go off-world? Oh, he's got it. So they were trying to unlock what is the the key microbes, especially for aquatics, if we're going to go to Mars or the Moon. And what they found was, out of all the 50 plus different farms that they went to, that NASA did the genome, I forget what they call it, where they look at all the different genome of all the different microbes that are there, and it was 167% more diverse in the least diverse aquaponic system compared to the most diverse soil. And there was just a ludicrous amount of difference in the microbes. And you can check it out. If you don't believe me, you're more than welcome to take a picture. And so there's 3 or 4 studies that feed into that. But one of the farms I helped out in California participated in that study, and that's actually how I found out about all of this stuff. But it is a published study you can check out. But when you combine the aquaponics with soil layer with the dual root zone, which we'll talk about, you can get even more diversity. So, and again, when you have more diversity, what's that going to do? It's going to stimulate the immune system of the plant and increase the terpene levels. And what happens when I increase my terpene levels? Well, it's a cannabinoid. A cannabinoid is a terpene plus a phenol. So now I've increased my terpenes and my total cannabinoid levels. Just like they talked about, like Elaine was talking about, the more biodiversity, the more terpenes, the more cannabinoids. Exactly the same way. It's just one's an aquatic microbial web, one's a terrestrial microbial web. That's the only difference. People trip out so hard about organic hydro being, oh, that's, that doesn't work, or it's just, chemicals or whatever else. And it's like, no, they're identical. Just one's in a hydraulic solution and one's terrestrial. That's the only difference. But they have all different food chains, and no one's doing any research on the aquatic ones. That's the crazy part, especially when you see numbers like this, when they do a study like this. Nobody ever thought that. I know I certainly didn't, and this is a study by NASA. This isn't just a bunch of, a couple of, some random kid, trying to get a PhD or something that maybe didn't do all his research. This was well studied. So it's really amazing to see, how little research is done on this aquatic food web and all the mineralization of these different microbes. It's really, really, really wild to think that no one's doing that. So again, anyways, we talked about that. So the role of microbes, they again do all the heavy lifting. They're going to break down everything the same way they do in soil. They just do it in an aquatic way. And the aquatic ones can do things much more differently and with different efficiencies than the stuff in the terrestrial. We've also done studies with raft beds and DWC with cannabis and against controls, and along with media beds where we had zero or almost no detectable mycorrhizal fungi with the microscope. And they still had higher CBD levels than soil controls. Why? Because there was an aquatic microbe that we still haven't been able to identify yet that was playing that similar role of stimulating the plant to produce that microbe. So it comes down to biodiversity. It doesn't necessarily have to be fungal or bacterial dominant, at least in my opinion. It just has to do with diversity. If you have the right diversity, and it's diversity that's not attacking the plant, you're going to have a better stimulation. The same way you're getting vaccines. You're exposed to these different types of microbes and building a response to it. Well, that's what the plant does when it triggers the immune system response that triggers that terpene production. In the exact same kind of way. That's why anytime you're putting compost teas, you're putting your ferments on. What are you doing? You're increasing the diversity of the root zone. Again, the same exact kind of thing that we're talking about and doing with aquaponics. So we talked about that. Okay, so again, no one's really doing anything research on the aquatic microbes at all, really the last couple of years. So who here knows what Mulder's chart is or has seen this before? Awesome, so we'll go over this then. So Mulder's chart, think of this as a top or a teeter-totter, but a round one with a pin in the middle, okay? So you want to keep this level. And what I mean by level is everything needs to be in ratio. So for example, for aquaponics, I want a 2-to-1 calcium to magnesium ratio. So if my magnesium is 25 parts per million, I want my calcium to be 50 parts per million. But I also want a 3-to-1 calcium to phosphorus ratio. So I'm going to make sure that in that scenario, I want my phosphorus to be at 10 ppm, because that's going to help ensure that my calcium and magnesium is in the right ratio to be bioavailable. So that gives just a quick example of 3 different microbes, or 3 different nutrients. But by saying that, so it's important about your keeping everything in balance. Another great way to think about it is that, okay, so I can stimulate a forced immune deficiency if I put it on a couple of plants on a closed loop system, a 500-gallon aquaponic system, put a UV sterilizer on it. And what that's going to do is it's going to lock out the iron, okay? And it's going to lock out the zinc. And because it's going to break the chelation on both of those. Because zinc is generally, we use a DDPA, or it has a natural humic chelation, or the iron is DTPA or EDAHA. Depending on the chelate, and when what happens with the UV is it breaks that. So what happens is it makes it so there's no iron or zinc available. Well, what happens is it makes it so there's no phosphorus available now. Well, when I run the UV sterilizer, when the plant's going to show a phosphorus deficiency, they turn purple. Now, if I dose that, if I say look at the plant tissue, and I say, oh, well, that's clearly it turned purple. That's a cannabis, or that's a phosphorus deficiency, just like all of us would if we looked at a leaf chart. Right? So we go to the store and we get monopotassium phosphate, or we get rock phosphate, and we dose that, or we put phosphoric acid, but it does nothing. Why? Because that wasn't the problem. It was because the iron and the zinc weren't available that locked out the ability for the plant to uptake the phosphorus. This is why it's important to do water tests occasionally, when you are doing aquaponics or hydroponic solutions, if you're not going to do regular changes on your reservoir, you're not going to build that base back up. Like in aquaponics, we don't ever dump our reservoirs. You know, I'm testing every 2 to 4 weeks, and we just make minor nutrient adjustments with organic solutions or with microbial inoculants, with ferments, by making different nutrients available with those methods, depending on what it is that we need and how organic they're trying to be. But when you think of it this way, again, everything has to be in ratio. If I put too much of something, it tilts down, and now when it hits the ground, everything crashes and something starts dying, or it's showing a deficiency, or it's making that plant more available to insects. And you know, if I don't have silica is a huge factor in stimulating the immune system response in plants for both molds as well as heat and cold stress, and all different kinds of things. In fact, just this past 2 weeks, I've had a bunch of people in the south that were using potassium silicate as part of their pH up regimen, and they did not have the same frost damage of the guys that were not using that even, in the next couple houses down in Texas. So, and that was the guy I was talking about on the podcast last week. Don't take my word for it. Listen to the guy that had happened. So just to think about it that way, but also think about your microbes in that same way. You know, if I have too much trichoderma, they're going to eat everything and eat all my fungi, and they're going to wipe everything out, and everything's going to get imbalanced. You know, if I have too much lactobacillus, even, it's going to have some negative impacts. You can have too much of whatever. You know, it's the reason why you have to really watch your ratios when you're doing your compost teas, and why you need to get a microscope and look at your compost tea. If you're making compost tea, you should have a scope. Scopes have come down, and you can get $50, $60. You can get a scope. If you don't have $50, $60, like, should you really be growing weed? Like, for real. You gotta go hustle another 8th is what you need to do. Maybe 2. I don't know what the prices are in Michigan these days. So think about it this way as well. So you have your microbes, and they're like your chefs, okay? Or not your microbes. Your nutrients are like your chefs in this scenario. And your plants are your nutrients. Or your plants are your customers, I'm sorry. Now, a guy in a food truck, which would be like a hydroponic system, in a sterile hydroponic system, can do, 5 customers maybe every 7 to 10 minutes. But if I give that same chef, a prep chef, a sous chef, a host, a bus boy, whatever else, they'll end up being much more efficient. So now he can serve 10, 20, 30, 40 people in that same period of time. That's the same way that microbes work. They're like that restaurant staff. They make that same nutrient significantly more efficient, and that's a really simple way to explain to people and a simple way to make people digest. That's why it's so important that you always pair, when you're dosing minerals, you're adjusting something, make sure you're dosing it either with a stimulant like molasses or a little bit of sugar to get those microbes to wake up and inject it right in the plant right away, or add it as part of your normal compost teas or whatever else, just add it in a smaller value. And again, you're coming in with guys with little syringes injecting those nutrients right into those plants and making it like little stormtroopers coming in and taking over. So what do we do with the fish waste? So we take the thickest, heaviest stuff and we put it into worm bins, and we make, so per 6,000 to 10,000 square feet, depending on the varieties and how long they're vegging them, we get almost 2,000 pounds of soil a year generated between from the earthworms. So between the fish waste and the leftover greens. So that's really a lot, considering, you wouldn't think aquaponics would generate soil, but it gives you, again, another revenue stream. We also raise lots and lots of red wigglers and earthworms, as well as blackworms. Earthworms and red wigglers can be sold to anyone who likes to go fishing, or anyone that has a garden, and the blackworms go to the pet trade. And then mineralization tanks work similarly. So what happens is we put a fish waste in here, we fill them up until about 1 inch or 2 above the conical, and then we have vortex brewers for the real big facilities. And then what we do is we put this air blower on, and it just blasts and blasts and blasts air, and it works like a super hyper compost tea brewer. And then what we do is after 3 to 5 days, depending on what we're trying to do, we'll shut it off, and the heavy material will settle at the bottom. And then we'll turn this valve, and this will pull all the clean water that's super heavily mineralized, and we'll put that clear water back in the system fire it up, do it again. And that's how we unlock significantly more nutrients out of our fish waste. And without contaminating the system, I can add anything I want to. If I'm concerned that the fish might have something wrong with them, I can always add a little bit of labs to consume that. There's actually a new study that Kentucky State's doing this year on how well lactobacillus does when there's an intentional introduction of a pathogen. So that if you had E. coli or salmonella or something like that, can that be used as an actual treatment and preventative when we knowingly introduce that intentionally? There's been a lot of evidence based on using lactobacillus in other aquaponics farms that had non-human pathogenic E. coli, which is really common to find in fish systems or any aquaculture system, and it's gone after we treat it with the labs. So it could be a great way, in the very short term, you might see this as a best practices going forward for food safety in aquaponic systems, even for vegetable and lettuce producers, because it makes your fish grow faster, makes the plants grow faster, it eliminates bacteria that you don't want, so all kinds of good things that you want. So here's an example of some commercial producers. This is one of the smaller guys I work with in Colorado. This is up in Green Relief Incorporated, which is currently the largest facility. They're a couple hours from here, actually. They're currently the largest aquaponic cannabis facility in the world. This is when they were first doing research, when they're trying to figure out whether or not I knew what I was doing with the dual root zone stuff. So they put them on the rafts. They actually still use this method up there now with the dual root zone with the soil layer above a DWC. I don't know why they still do the DWC, but we'll talk about that later.
Where was this at?
This is in Canada, just outside Toronto. Yep. Okay.
Is that like styrofoam with net pots in them there on the left?
Yeah, so it's styrofoam rafts, and then there's pots with screen bottoms that have soil in them above that. So what we found is the soils, having a soil layer and the mycorrhizal fungi is very, very important for certain types of plants in order to have them properly flower off, as well as with lignin production. And we also did a lot of research with fruit trees. I've grown probably 18 different species of fruit trees in aquaponics. And what we found was when you give them giant dual root zone pots with about 60 to 70% soil and the bottom portion flood and drain, that really is the sweet spot where they have enough mycorrhizal fungi in the root system to actually get adequate lignin production and all of the actual things that the plant needs from the mycorrhizae, and then still get that accelerated growth at the very bottom with the fish waste and the minerals and all the good stuff that the fish from the fish themselves. So I've done all different types of experiments. I've also grown over 150 different types of herbs in aquaponics. We did all different types of experiments with what can you grow, what can't you grow. One of the most exotic ones I've personally grown like repeatedly was osha root, which is extremely hard to grow in a commercial type setting. We were doing it with ease in wicking beds. All we had to do was introduce some of the mycorrhizal fungi, but I took a little bit of soil from a wild collection spot in Colorado, and I didn't have to take the plant, I just had to take some soil right next to the roots and introduce that into that soil layer. It would colonize it just fine, and then I could grow the osha root, which is about $80 to $90 a pound dry, and is wild, over harvested in the United States. The wild population is in danger right now in a lot of different states, so that's definitely one, if you're looking for a non-cannabis one to grow for a decent price. It grows almost twice as fast, so you can harvest it after about a year in aquaponics. Whereas traditionally in wild harvest, it's a minimum 2 years to harvest. It just packs on a lot more mass. That's true for most plants. Garlic, is everyone here growing garlic and knows it takes about a month or two to germinate? It takes 4 to 7 days to germinate in aquaponics. Just to give you an idea of how the microbes radically change the plant growth, and no one's studying any of this. No one studies the hormone, why is it different with this? And what microbe and what microgroup or microgroup species is triggering that, because maybe we can do that in soil if we just take that and put it over there. A lot of these microbes will live in soil or aquatics, just about 76% of them will live in both environments given the right conditions. So it really is something that needs a lot more research, and there's no money in it, no one's throwing money at it, no one's doing any research on it, but some of the ridiculous stuff that we found, as far as accelerating growth, it's like, I don't understand why. There's also a big company called Aquilitas going up in Nova Scotia. I believe they're going to be almost 1 million square feet. Last time I read an article on them at least. And then there's another company called, I believe, Deepwater in BC. And they actually raise salmon, but they're decoupled, which is a little more complicated system. So you have media beds versus DWC versus wicking beds versus dual root zones. So with media beds, they're really awesome, but you don't have a way, to supplement any of the plants individually, which is really important, especially if I have different cultivars. I need to be able to supplement those different cultivars because they're all going to have different feed rates. They're going to want different things. They might want a slightly different pH in the root zone. DWC also lacks the ability to supplement. We've also found almost across the board, when we do DWC with Aquaponics with the lower nutrient levels, they end up fluffy and airy and don't get proper bud hardness, which is okay, I guess, for hash, but even then they don't really seem to yield right. When we do add that soil layer, it seems to make a 9-day difference with the yields. Wicking beds, they're really awesome, but what we found is right when we finish up, and anyone that's done SIPs has probably seen this once or twice as well, when they come right to the end, when they finish off, the same way as the plant starts to eject some of its leaves, it starts to kill off a portion of its root zones. And the aquaponics, we have these awesome mineralizing bacteria, but they'll start to break down some of the early root sections that are starting to die off, and actually occasionally cause some root problems. I think if we did a little bit better probiotics, I think we could get around that issue, since I wasn't doing so heavily with labs and other stuff when we started off with that, but it's something that I've kind of got frustrated with after 4 runs where we lost a couple of the plants right at the end. In the predictability and the ease of doing the dual root zone stuff, it just was, why I'm pulling my hair out when I have something that works, So this is what we call dual root zone planting. And what it is we have a layer of soil on top, a layer of burlap with a layer of media or lava rock or whatever you want to put in the bottom in order to have air and water go through. And what this allows is, you have your terrestrial microbes up here, your aquatic microbes down here, and when the water goes up and down, it works like a diaphragm, so it forces the air out of the bottom portion of the root zone, up through the soil like a diaphragm, and then when it comes down, it draws fresh air back down in there. So we get rapidly accelerated growth rate with both fungi and bacteria. Go ahead.
Do you have issues? You say you use just regular soil from outside. Do you have issues like cleaning it?
So I actually use compost, and once we have the facility running long enough, we generally just take it out of that 2,000 pounds of soil we're making anyway, and we're gonna just rerun that back through the system. I don't need to, I need a base amount of soil to start off with, or compost, but once I have that, I'm generating more than I'm using every year. So, we're having to get rid of some of that. And all you do is, turn it, put your nematodes in there to make sure nothing comes back if there was something you missed, and you're good to go.
I was more asking about getting the dirt into your system, because you say it's a closed loop. Do you have a way to collect that dirt or clean it? Or?
Oh, you mean after harvest?
Or I guess when I sometimes say I put cocoa in a pot or something, it drains through, it gets dirty in the water. Do you have a way to collect that so it doesn't fall or something?
So most of that will end up either in the bottom of the sump, or that'll end up in your. You'll have like a filter sock that drains back into the sump, and you just pop that off once a week, and you can take it off. But generally, it's not an issue. Your microbes and everything are gonna break it down after a while. It might be a little bit of sand or grit, but I've seen systems running for 4 or 5 years, and it's not a problem. The only thing we've had that can be issues: don't let your beds freeze. If your hydrogen freezes, it shatters into rubble, and it locks together, and it's really hard to plant in. But that's probably the worst I've seen, where someone's greenhouse side blew off. Anyone that had to deal with the blizzard in Colorado, or I think you guys got it pretty bad up here too. If you had a greenhouse, it probably got whipped open. But this allows us a lot of control, so I can do time-release soil stuff. So I can build a really good soil that has a long time mineral release. I can supplement. So how would you determine how much water goes in here? Okay, so let's just say you take a pre-measured cup. So I'm going to take one of these guys, one of Leighton's cups here, and we're going to take this, and you're going to pour in. We'll say it's 4 of these, and for the sake of argument, we'll say it's an 8-ounce glass. So it's 32 ounces. I'm sorry. In order for me to water the pot in the soil layer before it starts to drip out the bottom. Okay. I'm going to reduce that in half, so now we're going to use 16 ounces in that scenario, and that's how much you're going to water your soil zone. So as long as I supplement that with 16 ounces or less into the upper root zone, I'm going to re-moisturize that upper zone once I've saturated it the first time, and then from now on I can supplement that. I can even add something like yucca extract that would kill the fish outright. in that upper soil zone. As long as I water carefully and I do it that way. Now we have a manifold that I've designed that works where I can turn it on and it'll water 1 plant or 1,000 plants, or however many I want, with 1 pump, and it gets within a few milliliters difference. So as long as I make all those pots the same, it's super simple. I don't have to worry about it. It's also great if you're just running soil or hydro, because you're not going to use any more water than you need to. You know, once you know what your saturation is, it's just dead on, which is really nice. I actually built it originally for a vertical tower system, and had some issues with trying to, the first part venturing on me, and then came up with this, and it actually works great for watering the top half of the dual root zones. So we'll have that coming out later in the year. And then, so here's our natural, root soil breakdown. You have your, high organic stuff up top, and then your more, water and iron and other things. That's exactly what we're doing in a dual root zone pot. So you have your 2 biomes. Again, your aquaponics use a lot less water. So again, places like California or other states, you guys don't have to worry about this, but they don't have enough water in their water table to provide everything. And then you have states cracking down on how much water. I know in California for a while it was a gallon, or some places it was a gallon per plant per day. You're allowed, so it's not a whole lot. But if you're recirculating all of your water over and over again, you're just going to laugh whenever they put these restrictions in, and it doesn't affect you at all. Or you can be the one asking for these water restrictions at the board just to push your competition out, like depending on how much you hate the guy on the street, how much business he's taking from you. So island nations like Jamaica, Australia, St. Vincent, Barbados, they don't have enough fresh water on the island. They need to have recirculating systems if they're going to meet the demand for the tourists and the locals. There simply isn't enough water to grow for everybody, or to a lesser extent land, so you need stuff that's going to go faster. So again, the terrestrial areas are mycorrhizal networks, your terrestrial bacteria. You can supplement either with soil mix or through top watering or top dressing. You can get your nematodes and protozoa. You got your top water nutrients, and then your ferments. And then, yes, you can also do a no-till as well. So this is, anyone that knows the aquarium test bottles, this is a 3-month-old cabbage done with a dual root zone pot. It's stupid. That thing was almost 6 feet across. So this was actually one of the little girls that worked at the Aquaponic source. When we had our research thing, she used to help make all the compost teas and stuff for us. She was a really good little brewer. And she had a contest where they get from burpee seeds, they get the cabbages. And so she did put the cabbage in. We got a cabbage from her school. We planted it in a dual root zone pot and fed it like all the cannabis plants minus the potassium so it wouldn't flower. And it came out. It was the closest competition at her school wasn't even as big as one of our leaves. I mean, it wasn't even fair. So right here you can see that there's an air gap between there and the soil. Again, we're not trying to make a wicking bed. We actually want a separate water layer. We want to be able to water up top and have a separate layer of control. I can run this in one, up to half a pH different, point pH different, and I can run this, whatever I want to. And the flood and drain times don't matter. I know on most of our larger beds, we're between 7 and 14 minutes for flood and drain times. So it doesn't matter. Again, it's working like a respirator. As long as it's getting that fresh air, when it comes back down, you're gravy. That's why it's important to use burlap or some kind of other root permeable barrier that's going to prevent that soil from going down, because you do want those 2 separate layers of control. So again, here's your how it's laid out. Planting depth is important. You don't want to have that soil into the bottom. And this is what happens when you do a side-by-side. So here's an example of the side-by-side with the tomato. This tomato here had 44% more flowers, 42% more fruit, and tomatoes that were ripe 2 weeks before the media bed one. And it was just Pro Mix with no supplemental nutrients. Simply the fact that we had the Pro Mix with the mycorrhizae and no supplements at all. And that's it. That was just the, basically mostly just the mycorrhizae. And over here is a lemon tree. You can see the lots and lots and lots of blooms. They do kick ass. So here's the difference in roots. Not even close. It's laughable. The media bed versus the dual root zone. So, and then with DWC, it's a similar kind of comparison. You just end up with mass, and so this was a 1.5 long test, or not a 1.5 long test, but a 1.5 long grow out, and then before they started finishing. So And if anyone wants to see this, this was documented as well in the, what the hell is it called? Aquaponics Fest DVD or whatever. They have the whole breakdown of the whole thing. I don't know if they even still sell that or not. I think they do. So there are 5 different ways to control. I can dose nutrients directly into the water. I can dose into the soil. I can make a time-release soil mix. And I can use foliar sprays. If you do use foliar sprays, there's a great organic product. I don't know if it's organic, but I know it's natural, called Optic Foliar, Transport by Optic Foliar. I'm more than willing to bet they probably have it in this building somewhere. And then you can also vary up your fish food. Again, we talked about how you can change up your fish food for protein and phosphorus ratios. Dual root zone benefits. You get much faster growth. You can allows for a lot more conducive for mycorrhizal fungi. Cannabis and trees, again, we talked about a little earlier. The woodier the crop, the more it relies on that mycorrhizal layer, and the more soil you want to have in your dual root zone pot. You have the ability to run slightly different pHs. If I'm going to do berries, if I want to do raspberries or blueberries, I can run a much more acidic soil in that upper layer, and they'll do much better. Strawberries as well, like a more acidic soil. Also increased immune system in response in the plants, and it can be done in no-till if you do really large pots or even beds this way. Again, you can adapt this to whatever kind of method you want to do. The problem with the beds is that you don't get that same kind of diaphragm action. So we've had much better results with the no-till when we did it in larger pots. 70-gallon, 80-gallon pots worked really well. We've also done them with as small as 20-gallon and done 2 or 3 runs. I'm going to break this thing eventually. So some of the common issues we have with aquaponic producers, I also work 30% of the time with our certified organic vegetable guys, and it's awesome. You know how much less work an organic certified vegetable farm is than a cannabis farm? It's like a tenth the paperwork, and they moan and bitch all day, and it's like, dude, let me take you to a cannabis grow for like half a day. You'll be so grateful about the amount of paperwork you have. So we have to worry about pesticide concerns. There's no whitelists right now, and this is something that I've actually talked twice with the Aquaponics Association on, is that we need to come out with whitelists the way the cannabis industry did, because 1, we're accounting for fish safety and the plant safety, and 2, if we don't do it, they're going to do it for us, and that's what happened in the cannabis industry, and we don't want that, because then you're totally pushed out. One of the other funny things I've seen, funny to us at least, is that people come in and they have vegetable farms that they have lights on at night. Well, there's ordinances going up now because of the cannabis guys about having lights on at night in greenhouses. So you got people that have been growing lettuce for 10, 20 years being told they need to put light depth on their greenhouses, and there's nothing they can do about it. So it's actually impacting a lot of the vegetable producers that are doing greenhouse stuff, and it was totally not the intention of the law. But now you got some guys on growing lettuce with tiny margins being told he needs to spend $80,000 for a light depth. He doesn't have that money, straight up. So it's something I talked to them about. I was like, you guys need to pay attention. This stuff is coming. It's going to affect just lettuce producers and stuff, and it hasn't got kind of clicked yet. Lack of standard SOPs. There's basically no standard SOP for aquaponics. You have the UVI model, which is a pretty good place to start, but there's not a lot of good stuff out there for that, and there's not too many people doing large-scale research that are actually getting good results with aquaponic cannabis, except for a lot of, well, not to speak myself up, but we've had pretty good luck with the stuff I've worked with. And then local permit issues, managing labor costs, constantly changing regulations, and managing biosecurity are all issues that we share as well. So lactobacillus ferments, I want to talk about this. So University of Kentucky State has a study that's coming in. It's going to be published, I think, in June or July of this year. They found that it made the fish grow 15% faster, the plants grow 18% faster on average, and it also, again, reduced the E. coli in the system, eliminated it, the detectable non-human pathogenic E. coli. So it really makes a huge difference. I also wanted to share with you guys a methodology that I've been working with. I haven't even talked about this with anybody yet, especially any groups, but you guys are going to get to hear about it. So you guys know about lactobacillus. It takes a long time to make, right? It's kind of tedious a little bit. It's a little, with the paper and the whole thing, putting the cheesecloth over. There's a simpler way, and it works better, at least in my opinion. Go to the store and get some kefir, like good actual Russian kefir. Get it on Amazon, and then use your milk and use the kefir from the milk, and then strain that and use that the same exact way that you would for labs. You can do it in 3 to 5 days instead of the 2 weeks you would for lactobacillus traditionally, and it'll even work when it's a little bit cooler. And you also get the added benefit of the fact that there's vitamin B in there as well, which the plants also really gobble up, and it helps accelerate plant growth. So to me, it's just, especially for commercial production, we started using this in a couple different places, and it's made a night and day difference. If any of you guys have seen my Instagram picture in the last couple days, where I had a picture of soil that we had treated with a little over a week earlier, just white, with hyphae. So it's awesome. They love to feed on it. Go ahead.
So instead of using a rice wash, you're using kefir?
Yep. Kefir, and then just throw in 2 cups of brown sugar, 4 gallons of milk, and some kefir grains. Doesn't get much simpler than that. Now you got 4 gallons of labs ready to go.
Do you suggest glass or plastic okay?
Right now I'm just using the Home Depot buckets with the screw on top because I can clean them real well. And that's more what I want to clean them in between runs. You don't have to, but to me it's just a much more simple version of labs. It's just, especially for you guys who have, if you're in a commercial thing, who has time to do all the rice washing and all? It's a lot of labor. This is so much faster. So just trying to take a lot of the same concepts and speeding them up or making them more commercially applicable. Go ahead.
So did you say you actually add the kefir milk to the
So you would strain it the same way that you would strain it for your labs? You strain the cheese off and everything? Yeah. So you treat it, otherwise it's just exactly the same. It's just how you get to that. Yeah, and it's a lot faster. So I also do a bunch of other, so I'm a bit of a mad scientist at home. Josh has actually seen some of my crazier stuff because I've shown him some pictures of some crazy stuff. Josh and Kelly, I think I've showed them some funky stuff too, but I like to take different Korean natural farming microbes, separate them as best I'm able to, and then throw different nutrient inputs out. And let them eat different things and break down different amino acids and different proteins and get all kinds of cool stuff like this. I splitted phycocyanin. Who here knows what phycocyanin is? All right. So phycocyanin is your base building block amino acid for chlorophyll groups. Chlorophyll A through E, or I don't remember what letter it goes up to these days, but I think they added a few letters since I was in biology. But it's your most complicated molecule for your plants to make in order to make more chlorophyll. Well, if I add this to the plant, either as a foliar or through the roots, it works better than any PGR you've ever seen out of a bottle. And you can drink it. So if your kid gets into it and he thinks, oh, this is cool blue liquid, you're totally fine. You might have a stomach ache, you might have the runs, but it'll be all right. A little Imodium, a little rice. Save the rice from the KNF and use it to plug up the kid. So this is some of the other cool stuff. Again, think of KNF, think of this fermented microbes, lactobacillus, stuff from kombucha, kimchi. Throw different plant inputs at it. Take kelp, take all different types of things, and throw it at it and see what comes out the other end. Because you might come up with something cool. But this is a lot of stuff I'm working on documenting. I have a book coming out later this year. It's going to make all this stuff simple and give you guys, fill in a lot of the gaps and stuff like that. Along with some of the research that goes with it and some of the cool stuff we found. But this is really what I'm trying to, get research to fund right now is I want to sit down all day and throw this stuff up. And how this came up was we were trying to figure out ways that we could increase growth rate without hurting the fish. I can't use chemical stuff. I have to rely on microbial stuff or plant-derived amino acids or other things that are going to have no impact. So it kind of forced us into this pigeonhole that had made us go down some really cool microbial rabbit holes and give us some really interesting results and show us that we can do some things with a lot less energy. The only other way typically to produce isolated phycocyanin is that you cook it down in a big oven, which is extremely energy intensive. So there's all different kinds of ways, and again, think of KNF and a lot of the, especially ferments, like a machine. You put inputs in, you mix it with the different microbes that are the machine, and you get different outputs out. Don't think of it as a set formula. You see a lot of people with KNF, in particular, like it has to be this much of this and this much of this, and this much of this, or introductory natural farming. Really? That's kind of crazy. We don't do that with anything else in cannabis. When else do we allow ourselves to be fitted into any bracket or rule set? That's kind of the opposite of cannabis culture to begin with. It's just not what we do. That's why most of us don't have 9-to-5s. That's why we grow weed instead. Because we can't deal with that shit. Right? And again, most of the stuff that we've come up with so far with the fermented stuff is all drinkable as well. So again, if I have a bunch of kids in the house and they get into the cabinet, no big deal. Fermentation tanks to help further unlock more nutrients from your fish waste. Root Guardian is up there. I would not normally recommend Root Guardian. Root Guardian is only good as a nuclear bomb to come in if you get fusarium or botrytis or something else like that that's starting to attack some of your lower growth and you want to prevent that from getting up into your bud rot. You come in, you nuke it with that, and then you reintroduce your microbes because the trichoderma is going to wipe out pretty much everything, but it's going to do too much. But it can be used as again, to wipe the slate mostly clean and then build back your stuff. Anytime you dose trichoderma, you always want to dose less than 1.7%. If it's in a micro group, if it's over that, it's going to dominate. And then why are you doing that? You're just screwing your diversity. Yeah, I won't go into too much. But with Mammoth P, the one thing I want to mention with Mammoth P is the fact that by using this, especially with lettuce guys, and to a lesser extent with cannabis guys, almost completely eliminates the need to have any additional phosphorus added into the system because it just mineralizes that. Really, really does a great job of mineralizing, in particular fish waste, the phosphorus out of that. So it can be a really, really, easy way to, instead of having to, have a supplementation. Silica. Silica is really frustrating to me because people don't talk about it ever in aquaponics. And you guys saw Elaine's chart earlier. What was the very top thing on that chart? The very top one was silica. So why do people still to this day in hydroponics say that it's not a food nutrient required? It should be in with macros because the target level is 860 to 100 ppms. That's a macronutrient. What are we doing? It's super, if you already do aquaponics, it's super simple to adapt to your normal aquaponic regimen. Simply replace your potassium option with potassium silicate. So if you're doing potassium carbonate, or potassium hydroxide, or potassium bicarbonate, just swap that out with potassium silicate. Make sure you do occasionally dose potassium bicarbonate so that you keep your alkalinity up. But it really makes a night and day difference. You can also do horsetail ferments. You do lactobacillus ferment with horsetail in it. Just make sure that you harvest horsetail from a safe place. Horsetail loves to bioaccumulate heavy metals. So don't get it right next to a road and be full of cadmium from the catalytic converters. Don't get it downstream from a mine. Be mindful. Go find a nice patch of clover and a little stream running through it and get it from there. Just be mindful when when you're collecting stuff for ferments in particular. Be mindful you could be bioaccumulating heavy metals. So be really watch for your collecting stuff when you are putting it back into the system. So this is a really cool project that we got a chance to work on in southern Longmont. So this is we did a whole CO2 supplementation with oyster mushrooms. We had a barn next to the greenhouse, and we did both the incubation chambers and the fruiting chambers. The incubation chambers we did not have fish tanks in. In this one you can see the fish tank, as soon as I find the laser, right here. And then the blue tank down here. And this allowed us to have the humidity with the mushrooms above it. And then the mushrooms, we had these all set up with closed loop cabinets. You can see the ceiling right there. And how these worked is they had CO2 sensors in them with fans. And what would happen is anytime they build up to 2,000 ppms, it would drop it back down to about 700 ppms in the fruiting chambers, and then flush that CO2 into the grow room. So that this way we could actually turn a profit off of our CO2 production. If anyone's interested, a real good friend of mine, his name is Nick Arnold. I can send you his contact info. But he did a bunch of research with trying to figure out what is the square footage and the cubic feet of mushroom mycelium we need from a typical commercial operation to fully supplement something like a cannabis grow. And he's one of the coolest projects I've had the pleasure of working with, and he's a really awesome guy. He was based out of southern Longmont. He just moved to California. I forget where his exact town is he's in now, but really, really awesome dude. Nick Arnold. As his farm was called Turtle Island Farms. So you can probably find some more videos online of it. But we did a whole bunch of cool research with him, and he's looking to do some more work. So if you know anybody that's interested in that, he's super down to work with you. He'll design the whole facility for you. Earthquake proofing. So this isn't something that you guys have to worry about a lot, but we'll breeze through it real quick. Making sure you trench out your grows, your piping, so this way if there is an earthquake, it can flex around without having to actually snap. If you have an earthquake and it's not hard clay, this picture is actually from Jamaica. It gets a chance to move around. The original capital of Port Royal was in Jamaica, and it actually sunk into the sea when they had a big earthquake. So when you have the gravel, it allows the piping to float around and not get broken. It's super important and super simple. And you can see our geothermal. Oh, we didn't get that far yet. There we go. I'm gonna put that slide after these. So this is an example of one of our geothermal methods we helped develop for aquaponic facilities. This is on a 50 by 30. So these are 2 solar panels off the roof of a house in Boulder that we got for free on Craigslist. And we built a frame out of some old wrought iron, and that had an insulated pipe that went underground into the greenhouse, and you can see it came into this PEX line. This is the same yellow PEX line you get for a gas line at Home Depot. Just cut the plastic off. And then you put your ends on, and then we run that on a closed loop of glycol on a little solar powered 100-watt pump. It was on a thermal switch. Whenever the water was warmer in the panels than it was in the water in the greenhouse, it would turn on and heat it up until it got to 74, and it would shut off. These are really awesome for adding a lot of heat for no extra cost in the middle of the winter. The other cool thing is you can run them in reverse as heat radiators. So if it's 105 or 107 out in my greenhouse during the day, even with me doing everything I can, especially in Michigan, it's a little more humid here. Evaporative coolers don't quite work so well. What I can do is that heat in the greenhouse is going to be absorbed into the water. It's going to heat that water up, but when it does so, it helps cool the room down a little bit. But what you do is, so now I have the water's like 76, 77, 78 degrees. It's too warm for those fish. If it gets up into the 80s, now the oxygen level's getting pretty low. And while it might make the plants grow faster, it's certainly going to make, much more likely those fish are going to, die or chance of pythium or other problems. So what we do is we flip these on at nighttime. And what happens is if it's colder outside than it is in the water, this just works like a radiator at night, so you can bleed that heat back off so that you have that ability to absorb more heat the next day. You can use this again to drop your greenhouse. It will lower the temperature of the greenhouse 2 to 3 degrees as a cooling method as well, because it's sucking that heat in, as long as you're cooling. You can also run cool lines and wick it off from the ground and cool coils. I don't have any of those in this picture, but we just put in 2 miles. A buddy of mine just put in 2 miles of coil for a facility in Colorado for cooling in the summertime. So this would be how you do it. So this is like in Canada. So and here we have a big giant pond in the middle. We'd hang our nets, put our fish in. We'd have your walkways above that, and we could pull them, at the end. And then what we do is we put a platform above this, and then we'd have, all your grow beds on top of that platform. So, and you'll see how that works in a second. So this is the geothermal portion of the greenhouse. You can see we dug down, about 8 feet, all said and done. And here's the PEX line. Now this is something that failed. And I wanted to include this here. So we put PEX line down at the very bottom of the geothermal. It did nothing. It was just a waste of money. So don't do that. But what you want to do is put the tube, you want to have a manifold of 55-gallon drums or similar type tubing down to a bunch of skinnier pipes. So these are 3-inch or 4-inch drain pipe. And what you do is you do them in rows. And the important thing is that all of them are the same length, because if they're not the same length, you don't get the same airflow. You see companies, a couple of greenhouse companies have square grid geothermals. Well, what's the problem with the square grid? I have vastly different airflow on that far side of that geothermal than I do in the middle. I'm going to have great airflow in the middle and horrible on the outside. And what's going to happen on that outer loop? It's going to grow mold and all kinds of other stuff because there's no good airflow in there. And then now you can introduce, powdery mildew, and you got a place for, black mold to grow and other things that, if I'm doing microbial testing, that's going to bite me in the ass. So I can't have that. So when you do them in the same length, you get even airflow across all of them, you get even resistance, and you're not going to have that problem. That's why it's important. And here you can see the different layers. And so this is a much better representation of the diagram of how you do it. You have your central intake manifold here, takes air from the hottest portion of the greenhouse and pumps it underground, and then it kicks it back out the other ends. You can also take this and stack it, so I could put 2 or 3 triangles in here and just alternate them like teeth, you know, on a pumpkin. You know what I mean? And it'll work just fine. But does anyone have any questions on that? This to me should be required by law because it you know, in the wintertime I get 57-degree air and I'm building 57-degree air and up. In the summertime I have an air conditioner. I could put a solar powered heat fan on there for 100 watts and I never need it doesn't cost me a dime to run. You know, with a thermal switch and you're good to go. Go ahead, gentlemen in the back.
Is that how you're moving the hot air down then from the ceiling?
Yep, so the fan would be up here, and you're taking the hottest air and rebalancing it out. The whole idea is to bring it to equilibrium. And again, you're going to pull 57-degree air out of the year-round. So if it's the wintertime, you're building up from that. So instead of me building up from 30 degrees, even if I have to rely on a backup propane or something like that, it's a lot smaller of a temperature gradient, which means I'm going to spend less propane. There's another gentleman.
I had a question, but it was on a separate topic, so should I just go for it?
Sure.
I get the mechanics part of, this is my first time I've really dug into aquaponics, right?
Sure.
And the fact that you said that there's so much of a wider microbe band
Yep.
really kind of blew my mind.
Yep.
Which begs the question, what does the weed taste like, right?
Sure.
Because it could bring up like secondary terpenes that we don't usually taste, and it could taste radically different, perhaps not even good.
Oh.
And I've never had this stuff.
Sure, so it's much more flavorful. And we've had much higher terpene levels. We've had as high as 7% terpenes on single runs with that. We have extracts we've done a single pass, well, it's a separate topic, but as high as 19%. On a single pass. So, and stable, you know, anyways, that's a different topic you guys can talk to me about after the tech. We're actually working on, yeah, anyways. We'll talk about that after the presentation. VPD, so I threw VPD in here because, oh, I'm sorry, there's a guy behind you as well.
Yeah, just that there's a lot of infrastructure cost in that system. I'm just curious, like how much you really, looked at the, benefit versus embedded cost.
Sure, so there is additional construction costs in the beginning, absolutely. This is much better for new construction. If I had an existing greenhouse, and I actually have an existing greenhouse in southern Colorado that we're adding this to that's already built. What we do is we dig a hole in the corners. Like you would run these manifolds straight down the same way they are, but you'd run them as rays outward, out into the yard with a little kind of rain cover at the end. And then you just run them out from the greenhouse, and you can run them as long as you want. So if I was doing, wanted to have a really large temperature gradient, I could actually run a 200 or 300 foot long run, with an outtake on the outside, and then what I'll do is I'll put a fan on the inside of the greenhouse that's pulling air in through that, so that I don't need to run power out to the ends of all those lines. Does that make sense?
I mean, if you've got great anecdotal evidence that this is working, that's great. I look at it and I think, like, how much really air exchange, heat exchange is there?
Oh, it'll make a 12 to 14 degree temperature difference in the summer. That's a, go ahead.
So I grew year-round tomatoes in Minnesota, Minneapolis area, in a greenhouse with this design. I had one forced air blower in the greenhouse that's grown year-round, and it was like, I think it was 180,000 BTUs, and I was using natural gas. It was record cold in, I think, 2013. And there was 40 days where it was negative 40. And I thought, dude, remember this time. Remember how much this bill is. And that's like, probably the worst year ever going to happen. My natural gas bill was $950. So and it's a 30 by 100 foot one. Now I'm in Bellingham, Washington, right? It's a totally different climate. And I built a new greenhouse. And I thought, oh man, it doesn't get as cold. I'm too busy. I need to get this thing down. I'll put something in separate on the side later. I have yet to do it. In the fall, when I was harvesting my crop in October, it gets down to 45, maybe 50 degrees at night. I spent $3,000 in 10 days. So I currently spent $3,000 in 10 days with that system. So I'm having to go back and do this shit.
Yeah, and like I said, yeah, like I said, it'll literally cut your costs up. Now, when you stack that with the climate control costs, and you stack that with the reduced water, now you have a whole lot less, overhead. Now you got more money for things like buying new equipment, putting better lights in, paying your trimmers better. Okay, maybe not that, but the other thing I want to talk about too is VPD. There were just something that wasn't talked about last year, and I wanted to throw it in here. Does anyone here know what VPD is? It's super important. Vapor pressure deficit. Yep, and it's the difference between the amount of air that the air currently holds with more moisture the air currently holds versus how much it can hold when it's completely saturated. And what this is based around your temperature and your leaf surface temperature, not the air temperature, which is often misspoken on, and the humidity levels. But there's a third component that's also not talked about, which is air movement. It doesn't matter if the temperature and the humidity level is dialed in if there's no air movement, or if the air movement is too slow, because it's still going to slow the respiration rate of the plant, which is the whole point of jacking up the VPD in the first place. When the VPD is dialed in, you get the maximum respiration rate on your stomata on the bottom of that leaf, and that's going to allow you to have the best respiration rate. When they're breathing the fastest, they're going to produce the most chlorophyll, which means they can produce photosynthesis the fastest and produce the best cannabis and the fastest growing cannabis. There is an example of a VPD chart. You can find 80 bajillion of these on Google. This one is not mine. I did not make it. I claim no credit, but it is, a great example. So with this, we'll go ahead.
Sorry, is that leaf temperature or is that room temperature?
Leaf temperature, yes. So the ideal range would be 84 to 88 degrees, ideally 86 to 88 degrees Fahrenheit, or 30 to 31 degrees Celsius for you Canadians. I don't think there's that many of you here. There's a couple. You're looking at 80% humidity. How many of you would have thought to run 80% humidity if you're running at 80 degrees in the room? Most of you would think that's going to bring mold. Or traditionally you're taught that's going to bring mold, but it's not. You'll get extremely accelerated plant growth, and it'll just blow the socks off of anything you've seen before. Every single plant in that room will be praying to that light and begging for more nutrients and just cranking. Any questions? Okay, in the back.
Is there a correlation between room temperature and leaf temperature?
Nope. As long as your leaf temperature is the right temperature, is the only thing that matters, because the only thing that's determining how the respiration rate of the stomata, which is the only thing that matters. That's why I like laser temperature thermometers. Just walk around the room and spot check. And then that's another great way to know if your lights are too low. You're cooking your plants, the lights got to get higher. And it's so common, especially in commercial grows. I walk in, the plants are cooking. They all look like, they're like, oh, it's mag deficiency. It's like, no, it's not magnesium deficiency. You're just roasting your plants. You can also just gun one of the leaves at the lower part of the canopy that's getting shaded. Yeah. Go ahead.
So, I typically don't like to go above 75% humidity just because I don't like mold.
Sure.
And Ohio's a lot different of a place. So would that change how much humidity you would allow inside of a greenhouse because of the actual...
Just leaf surface temperature. Again, follow the chart. Now, the biggest thing I see people do wrong is they don't bring the humidity down at nighttime. That temperature needs to be tied to the humidistat, which is tied to the, your dehumidifier. And you have to also be careful. You're going to run dehumidifiers and try and save that water and put it back in the system. I know Quest dehumidifiers are aluminum, and they're not a problem, but I know some of the other companies out there run ones that are zinc and copper, and that will kill your fish. Not in the beginning, but after a couple months, you're going to build it up and it's going to start killing shit. So that stuff I've seen people do. I've seen people ask me if they could pleasure themselves into the tank to feed the baby fish. I've had people put OxyClean in the sub tank because oxygen and fish, and it'll make it clean, right? And Windex for aphid spray because they read it online. You name it. Go ahead.
On that note, do you just top off your fish tank with tap water, or do you let the chlorine evaporate?
So that's a great question. It depends on what the chloride level is. So typically, we want in an aquaponic system the chloride level to be 70 to 110 parts per million in order to get the fastest microbial replication rate and the fastest growth rate for our microbes. It's not a problem for the fish until you get above 200 parts per million. So that's EPA standard. I generally say 180 personally, just to be on the safe side because it gives you some wiggle room. But most of the time, people freak out and get rid of all their available chloride, and unless they're doing really good aeration, they're actually slowing plant growth. But if you do have a really bad, and Elaine would shoot me if she was here, but I really like potassium thiosulfate for treating water. It's like a shot glass per 1,000 gallons or something. You're using it at such an amazingly dilute rate, it doesn't have an effect on fungi because of the rate that you're using it, and it's used for mass agriculture. If you're a farmer and you have to resort to taking city water because, water problems, whatever, you actually use potassium thiosulfate in order to get rid of the chloramine before it goes out to the field. And the reason why it works is it separates the ammonium ion from the chloride and allows the ammonium ion to be nitrified, turned into plant food. So you're actually getting the most benefit out of it compared to any other methodology. You can't use sodium thiosulfate because I don't want to build up sodium in the system in a closed loop. It's a problem. You can use brassicas or avocados. Love both to export it pretty heavily, but brassicas in particular, and onions as well, will pull a lot of sodium from the system. Tomatoes are another one that will pull a lot of sodium per day.
Well water though? What if you have like hard water?
So well water, if I had a real high pH,
Parts per, like say you had 600 parts per million.
600 ppm doesn't tell me what it is.
I mean, around here is usually calcium, iron, stuff like that.
Sure, but again, I'd have to look at the analysis. If it's a good balance, I might not want to do anything to it. It might be great, But if it's super high, I might want to run it RO, or I might want to run what's called a cold sterile, which pulls out most things but not everything. Still leaves some alkalinity behind, so you have some pH stability. Those would be some of the options I would pick. Go ahead. There's a question.
Do you have a good place to test your water? Do you have a place to recommend?
Yes, so the people I like, MMI is not bad, that Leighton said earlier, but the guys that I really like the most, especially for aquatic testing, or if you're going to test your wells or whatever, is a company out of Allentown, Pennsylvania called J.R. Peters. You can find them online, they're called J.R. Peters, and they're generally like $42 to $50 a water test, and for an aquaponic system, if you're just doing a $50 water test once a month to balance your nutrients, that's not too bad, especially when you're doing minor adjustments. It's cheaper than what you'd spend if you're running, part A, part B of XYZ. A lot of people are still stuck on the baby bottles. But hey, that's how we all got started, right? We all got started with from Ed Rosenthal and Jorge, and just the other day, someone was asking me about Jorge's YouTube video with the PM and the peroxide. Don't do that. I love him. He's the first guy I ever learned from. I'm not talking shit on him at all. Just, we've changed. My point is that we've changed the way that we've educated ourselves. We learn more about things, and then we change the way that we do. It doesn't mean anyone's right or wrong. It means at that time that was the best information we had, and that's what we had to go on then. But we learn some new things, and we move on, and we change the way that we think about stuff. So, but I think people are so quick to cut people down. It's kind of crazy. People, they need to just chill out a little bit with everyone's so cutthroat because they're so stressed out because everyone's so squeezed right now. This year's really been nice. I'm sure Kevin's going to talk about it on Sunday about how everyone's kind of stopped with all that. Everyone stopped fighting, at least a lot on the West Coast, because it's about survival now. We've got to work together. We're all screwed, especially as organic producers. If we don't band together and we don't, we're going to get pushed out of the market. So it's kind of our only option. And it's really nice to see that happening this year and seeing significantly less infighting in the community. Not so much our immediate community, but the organic side in general. So stuff to avoid: UV sterilizers. They break down the chelation on many different nutrients. Auto feeders. Okay, your main input is the fish food. How long does it take to feed fish? 15 seconds maybe? And if the fish don't come up to the surface, maybe you may not have rogue electricity in there. Maybe the pH is off. Maybe the thermometer, maybe the heater isn't working. Maybe some asshole came and dumped glyphosate in the system. I don't know. But the fact that there's a difference in response means I now know to be further inquisitive about something with the chemistry or something that I might not be able to visually see. For something that takes 15 minutes, 15 seconds, why the hell would you lose that data input? That's insane to me. I mean, imagine a facility that was 4 times the size of this building. What? 10 minutes with a cart and some fish feed throwing out pitchers? It's just ridiculous. It's not a labor cost that makes sense. It's a liability to save a little bit of labor that you could save significantly better somewhere else. That if they do miss something, auto feeder's not going to tell you if the fish don't feed, you know? So, MBDR filters, they're pushed by a couple of different producers. They don't work. They micronize stuff. They cause silts. They clog the roots of stuff. They cause all kinds of problems. The mineralization is vastly inferior to doing offline brewing. If you have two separate mineralization tanks and you run them at different times, you'll get much cheaper and more predictable brewing. Not to mention you'll be able to test that and have real predictable nutrient numbers, whereas with the constant stuff, it's a little bit more all over the place. It tends to be just a lot more of a problem. They're hard to balance. They just don't tend to work as well. We've ripped them off of almost every system I've worked with so far. So, well, all the ones that had them, it's about 4 systems so far that have had them, and all of them ended up causing more hassle than they're worth, and all of them are kicking ass now that we've stopped making things more complicated than they need to be. There's what is it, a Z-Dep or whatever, that stuff is a nightmare. It makes your ammonia too high and a bunch of other problems. So yucca extract kills your fish in a few seconds. Saponin, the Native Americans in California and Oregon and Washington would take yucca root, they'd squeeze it out, concentrate the juice, and they pour it into the river and have the tribe go downriver and they catch all the fish that float to the surface. And then they eat them. So just a few drops, even if you have a lot of it in the soil mix you use, that can kill the fish if you overwater and you go crazy. And just because it's organic doesn't mean it's safe. Again, you gotta be mindful of that stuff. Some other considerations, moms and cloning, it can be a great way to increase plant growth for that. Again, we get almost double the growth rate in veg, which allows us to get on average 20% better yield compared to soil for the same growth period, and 15 to 20% depending on strain. But you will almost every time for the same growth period. It's not so much that cannabis will give you a better yield for the exact same size plant. It'll give you a terpene profile for sure, but it will give you a faster growth rate in veg, which means your starting point when you flip the plants is much larger than when you would, growing in soil. I have a couple plants growing in soil at home, so I've been around a lot. My roommate knows how to do soil, so and I'm not home enough now, especially this year. It's like watching paint dry. It's so slow. Like I know, no offense to anybody, but it's so slow. Yeah.
On your aquaponic systems, are you using regular cloning procedures, or are you actually incorporating aquaponics into your cloning systems?
No, so actually it depends. So all the facilities I'm doing, like commercially, we have everything's nice and clean. But in Jamaica, we did a bunch of stuff with moringa, and we were just taking moringa branches and sticking them right in media beds, and they would root in about a week and a half, 2 weeks, and we transplant those right into the field, and that was way better. Everyone's trying to grow moringa, knows the horrible germination rate with the seeds. They can be pretty tricky, especially if there's any H to them at all. So once you get that 1 or 2 going, they're so much easier to clone, and then especially that little labor, taking a bunch of cuttings, putting them in a vase, dropping them in a media bed, and coming back in 2 weeks. Anybody can do that. You don't need any kind of agricultural training at all for that. So it's really easy for people that don't have a lot of background and that kind of thing. Go ahead.
I didn't hear you say much about taking care of your fish yet, besides throwing some food in there, and they're in a tank. I mean, how are you extracting nutrient, and what else do they have besides water around them?
Sure, so the fish, as long as you keep your temperature and your pH stable, all you really need to do is feed them, and that's not really, that's about it. You can harvest, harvest them if you're going to use them for fish. If you are going to harvest them for fish, or you just happen to be an avid fisherman, there's a great product called an Ikigun. I-K-I-G-U-N. You can get it on Amazon. It's about $35. It's like a cattle prod. It looks like a hot glue gun that has a cattle prod in it. And you just put it up to their temple, pull the trigger, and the fish is dead instantly. So there's no suffering, there's no flopping. It's just quick, clean kill. Real humane, and that's how I would want to be put down. So, but that's about it. There's really nothing else to it other than just raising them for flipping them. You don't really have to do anything to them other than just keep them happy.
And you're just draining off a certain amount of water, and then refilling with water.
Oh no, we don't do any water changes. No water changes at all.
How are you getting your nutrients out then?
Oh sure. So I guess technically you could say we're doing a bit of a water change when we flush the nutrients from the radial flow separator into the brewer, but we're taking that and putting it back in the system after the fact. So we take the waste. You flush it out of the filter, it goes into the offline mineralization tank, basically what you guys would call a compost tea brewer. We compost tea brew it for 3 to 14 days, depending on what we're doing, and then we add that back. Once we turn it off so the solids separate out, and then we siphon it and do it again. So that's the whole roll of the fish. Gentleman in the back there.
Yeah. Do you change the food and flour or at any moment at all? Are you just feeding this consistently same diet to the
Sure, so actually what we do now for almost all the facilities I'm working with now, we have separate, I'll run 2 to 4 fish tanks in veg, 2 to 4 fish tanks in flour, and with enough sump tanks to support 2/3 of the facility being one or the other, or 3/4 of the facility being one or the other, as far as gallonage for the sump tanks. And then what I do is, instead of me taking all the labor time of moving the plants from a veg room to a flower room, we just dep that row, or that sets of rows, or that tunnel. I just put the dep on, split the 4 valves to change the plumbing over from veg to flower, and we're good to go. And the biggest difference is nitrogen level. If I run high nitrogen level in flower and aquaponics, what will happen is it'll make larvae bud, also reduce potency, it'll also increase chance of herming, you'll get foxtailing, and it's so ridiculous because you have companies out there, Nelson and Pate, that go out and tell people that you can't overfeed the fish, it's just more nutrients for the plants. Well, no, again, like we saw in Mulder's chart, ratios matter. You can't just throw nutrients, you can't say, if I just keep shitting on a plant, it's not going to go better. Like, it's not how that works. You can use too much. So, gentleman in the back that we keep calling on, he keeps getting picked up.
Using the aquaponic system for your cloning. And,
Yes.
And you're transplanting them into, say, soil or soilless medium. Is there any tricks to that transition, or they move right in?
Sure. So I always transplant generally into like a wicking bed pot. So they're like half-gallon cloth pots or solid pots that I'll just drop into or like little these biodegradable like half-gallon pots. Somebody bring them this time? They were at the last conference. Anyways, these smaller, kind of paper pots, and we'll raise those. We'll sit them in the bottom. They'll kind of work like a wicking bed, and then we'll transfer those that way. But I'm glad you brought that up because there's a little tip I wanted to bring in. Just the tip, actually. So when you take the clone, yeah, it'll be even funnier in a second. You have the clone, right? And you always have your tap roots. Your 1 to 4 tap roots you have on the bottom of it. Trim off just this much of the bottom of the root. So trim off the bottom of that tap root, which sounds a little bit insane to some of you, right? So that end of that, it produces a root inhibiting hormone that actually reduces branching of your root system and actually makes it grow straight down because it wants to find water or iron or other nutrients that it's having a hard time finding. But you're going to provide it with all those. It doesn't need to do that. So what you do is you trim off that little tip and it gets rid of that inhibiting hormone. So when you go to transplant into your soil layer, or even if you're doing regular soil, you don't have to be doing aquaponics. By week 2 and week 3, when against the control that you don't do that to with the same number of leaves, branches, the rest of that will look significantly larger and have a better leaf count because that root structure for a week and a half to 2 weeks after you transplanted it had none of that inhibiting hormone going on. I had to regrow that tip, and it really will make a big difference. And it'll be a little bit of a transplant shock, because you've tripped the roots, but it'll be a much bigger plant by week 3 every single time. And that's something that's super simple. Ultra low labor, which is part of the transfer. For your transplant SOPs.
That's a clones and not seed.
You get even for seeds. Yeah, even when you're transplanting, anytime you have a smaller plant and you're repotting, you take the biggest leaves and trim it. The only thing I wouldn't do that to would be like with fruit trees. That doesn't work the same way. Gentleman right in front of you.
If you were to do that with a soil base, like say you're in a 4x4 cell and you're going to transplant, would you wash the soil off in order to find that taproot and trim it, or just cut like the bottom?
No, it'll make itself known. I mean, if your taproot is not the bottom enough for you to find it, you shouldn't transplant it. I mean, you could if you really want to do it quickly, but I don't see a point. It's not going to hit a hard compaction layer and go sideways. It's just going to go. It's going to keep growing. So it doesn't really. It's not going to affect the vertical drop, if that's what you're asking. It uses gravity to tell. So it's not. You're not going to change that unless you put it upside down. It's not going to work with the aquaponics. Maybe in space. Again, it provides meat and additional revenue streams. Cannabinoids, again, we find higher total cannabinoids and terpenes in almost every single one of our tests compared to controls. I'm going to be working with 2 different universities in the next year, so we can do some peer-reviewed stuff. So it's not just me telling you that; it's actually like, here's how we did it, and here's how to replicate it, and now we can really argue. Really see the Facebook boards blow up. And then increased mold resistance. So we've seen huge increases in mold resistance with the dual root zone pots and aquaponics, in particular for squash and cannabis. I'm sorry, I didn't see your hand there, brother.
Oh yeah, I wanted to ask you, when you say spinning water, do you mean like vortexing it? Like on the last slide. It said like
water spinners.
Yeah, water spinners.
Water spinners is a piece of pipe with another piece of metal, like a piece of metal ribbon twisted, and it's supposed to create the harmony and the energy and the fairy blowjobs or whatever the fuck it is. And that's what it's supposed to do. It's supposed to balance the pH. I was working at the Aquaponic source, and this rep would come in and be like, "Oh, we got this device. You put it on here to balance the pH," and I'm like, how the hell does the chemistry work on that? Because unless you're like a physicist or something, you discovered something new, I think you're wrong. Again, reduces climate control costs by as much as, down to about 40% on average of a normal grow in soil in terms of winter costs, running it through the winter. Yeah, a whole bunch of different things. So thanks for watching. Is there a question online? I saw you had your hand up. Okay. So here's my info. I have a weekly podcast called Growing with Fishes every Tuesday and Thursday. If you're interested in learning more about Aquaponic Cannabis, I do have a class coming up at the end of April. I won't plug it too much, but you can check out more info on my website or just hit me up an email. And I also have the Aquaponic Cannabis group, Facebook Growers Group, Instagram, SoundCloud, iTunes, all the audio things. So, what questions do you guys have? All right, go ahead.
Fish per gallon, 1 inch fish per 10 gallons.
So you want about an inch of fish per 2 gallons for big production. If you're going in your flowering system, maybe half that, because again, nitrogen is going to fight you, and it'll fuck up your yields if you get it too high. So, go ahead.
How deep do you bury those manifolds that you talked about in the greenhouse?
Oh, for watering everything?
No,
the geothermal. So the geothermal, you want to go down below frost layer, like that's where you're going to start putting the cross ones. So generally 8 to 12 feet. In Michigan, you guys get some pretty brutal colds. So I'll go, if you can go deeper, go deeper. I know your water tables also are a little bit high here, so you got to balance that out.
Can water get into that?
Absolutely. And what you can do is you can take the whole thing out like a swimming pool and put a liner in. You can get like underground liners for like cisterns. There's like Aquascapes makes these like giant egg crates. You can stack, and then you can drive a car on. Like they're awesome. It's like a heavy duty egg crate. What they do is I used to do this on our Blood Good landscape back east. Is we dig out somebody's driveway and then put these big milk crates in, and then level it back up, put a liner in, and it would work like a cistern. So we put another liner over the top, and then they have the drain lines from the house's gutter lines that would go in, and you have a huge cistern built right underneath the driveway, that was there all the time. Or you could put them in their walkways or whatever else. Gentleman in the back?
Is there any way to use the compost tea from mineralization tank with soil?
Absolutely, yeah. You can use compost tea with directly into the water with the fish. I've had no issues with compost tea, again, as long as you leave yucca out. There's no, lactobacillus works really good in the tank. All your KNF stuff, with the exception of IMO4, which Chris will talk about a little bit, is perfectly fine to put in the reservoir. You can put IMO4 in the soil, it's a little bit sticky and a little bit too sugary to be, really for the rest. Gentleman on the left there.
Yeah, how do you handle the humidity issues? I'm about 3 hours north of here, and I grow in a greenhouse 24 by 24, and every halfway through September it's 40 degrees at night, but the humidity is 89, 95%. And I've actually had it when I've heated it with a pellet stove and run a dehumidifier. Well, it's still been so hard that it's darn near been dripping on the inside. How are you going to do this in an aquaponic system?
Sure. So there's an easy way to do it. So it's pretty cold at that time of year on the outside of the greenhouse, yeah?
Yeah.
So what you do is you use something called cold piping. So if I take, alright, screw it, I'm gonna start screwing with your starter.
Because one of the problems that we have is that you store all that humidity in the ground when you pump it down there, and then it comes back up when you're trying to heat it.
Sure, so if this was a greenhouse, right, and that piece of plastic is one end of the wall, and this line right here is another end of the wall of the greenhouse, okay? Now I'm standing inside the greenhouse. And this pipe that, or this stick that I'm holding here, these bamboos, this is going to be like a 4 or 5 inch diameter pipe. And I'm going to run it straight through the greenhouse, through the exterior wall, so it sticks out this side, and same way on the other side. And what you do is you put a computer fan or a similar size fan, inline fan, inside the end of this on a thermal switch, on a humidistat on the inside. And when the humidity gets too high, where you want to, it's going to turn this on and blow the cold air in. Well, that cold air, because the only time humidity is a problem is when it's colder on the outside than it is on the inside, is going to blow through this pipe. Now, what's that going to do? It's going to turn the pipe into a condenser. So if I put a drip tray underneath of that with a piece of liner or Durascrew, again, I can run this on a DC powered, 10 watts of nothing, and I can just put as many of these as I need. Again, use skinnier pipes so you're not blocking light during the day, but you can put, I put eight of them on it, 50 by 30 by 18, and it was sufficient for the humidity about 70% of the time. So it's very efficient, very low energy, and this is the kind of stuff we started to stack up. Again, with Aquaponics, that's one of my biggest advantages, overhead costs. So we started to stack up some of this passive control and really help, further increase our margins with the Aquaponics. But that was the best way that I've found so far for low energy. Again, it's just adding more condensers. It's still kind of a dehumidifier, but
Because the best thing that I found was just keep the cover up over the top, but go open sides on the greenhouse, increase more natural ventilation was keeping the humidity down, but I'd be concerned about the fish.
well, you could increase the ventilation, but the downside is, and you guys haven't run into this yet, but you will here real soon, you're opening yourself up to 1, hemp pollen, so you're going to pollinate your stuff, and 2, microbials. I had a cup entry fail for 2 parts per billion of a miticide from a discroll mite farm that was 2 miles away from my house. Sometimes they call them strawberry farms, but I literally failed a cup entry for 2 parts per billion. So if you crack it open, you don't have an HVAC filter, you're gonna kick yourself in the teeth. And especially if you like anywhere on the West Coast, you wouldn't fast state testing to resell your stuff, and you got to either sit on it for 6 weeks or destroy it, depending on what state you're in. So, you got to get away from thinking you can just ventilate. Like, it's fine for now, but that's not going to fly here too much longer. That's not going to be an option anymore. So that's what I would say. And you can put additional ventilation and just make sure that it's properly screened. Any other questions? Go ahead, gentlemen in the back.
I was just wondering, with your cold pipe system, you still have to have traditional dehumidification in addition to that?
I would, yeah. I would run like a Quest or similar dehumidifier and then the cold pipes. If you're building everything from scratch, low energy as possible, yes, I would do a combo of both. You always need a backup. Even with that solar water heating, we still had a tankless water heater that functioned identically for when it got too cold or too cloudy, too many days. But when we heat the water up, if that water is 72, 74 degrees, the greenhouse is going to be 72, 74 degrees. Like, especially with the thermal mass of the entire floor being fish tank or grow bed, that's all water that's at 70-something degrees. So you just run your coils through the grow beds and the fish tanks, and it's super simple. A little bit of initial investment, but your running costs are so much lower. Any other questions?
I was just going to add, if I can, onto that discussion. If you get a proper computer, climate control computer for a greenhouse, they can control the humidity through burping, the exhaust, but you need to also have a heat system, heat the air up, and then it can burp it out, right? And you can actually, while it's raining up in Washington, I can keep my greenhouse at 70 degrees and 60% humidity just through this burping.
I did that manually last year.
Manually, you can't do it. I tried it.
You have to live this.
Go buy the $5,000 hydro or whatever,
And a lot of times in the bigger facilities, they'll have what they call like a scrub room or a air treatment room, or there's another name for it too. But they'll run it, and it'll be along the edge of the greenhouse where the air intake is. Usually have the evaporative wall, and then a separate area. Sometimes they'll have UV lights and stuff. But you can have heaters in there or chillers in there, and pre-treat the air before it goes actually into the actual facility itself. And that can be a great way, another way to handle that issue. Any other questions? A gentleman in the back.
Yeah, so I'm trying to get my kids into growing some stuff, and I got like 5 trays of microgreens. I'm just growing some seeds and whatever. But my kid wants to get some fish, and you know, I was thinking, okay, so we kind of incorporated a small aquaponics thing. You know, it's just on the side of the room, just on a shelf. What do you think the smallest system I should set up? I mean, I went to the pet store. I just don't know.
Sure, there's a great, if you want something off the shelf, and full disclosure, the owner's a really good friend of mine. There's a product called Aquasprouts. It's a 10-gallon aquarium system. You can buy off the shelf. It comes with like fish food and pH balancer and everything you need for a little while. All in the box, and it's a great educational little kit, turnkey. Alternatively, just building one of the ones like I showed with a concrete mixing tray, and you know, a couple of plumbing parts, and you're off to the races. Was it Desert Aquaponics? I think also sells little grow kits and parts kits. True Aquaponics as well would be the other guys I would recommend you to get parts from, or you know, nutrients and stuff like that. He's a great guy, Roger Loper over at True Aquaponics. Is real great at answering questions for people. He's got a Facebook group called True Aquaponics, and you know, if you have a lot of simple questions, it's a real good place to get stuff. With, doesn't put up with people chewing each other out and stuff like that. He's good at his moderation, so he's a great guy. Any other questions? Yep.
I had a quick one about the burlap. Now, some of us, you know, we want to reuse waste streams, and I reused some burlap on an organic farm I worked on, and it had coffee beans in it, and some of it could have, you know, pesticides in that. Would that be something that...
Yes, in theory, you could absolutely absorb that and have it show up in the tissue. That's going to widely range on what it is that was in there, and you know, the exposure, how fresh it was when they sprayed those. There's a lot of variables there.
Gotcha.
Some burlap is treated also, the actual bag, so even if it's an organic product that got put in the burlap itself could have a problem.
Yep.
Be careful with burlap, guys.
Yeah. I get mine from Uline. So. Yeah.
Have you ever run LEDs in an aquaponic situation? And
Yep.
if so, like, do you still have to make up for the temperature difference and for the lack in IR in a situation where, you know, like you're saying the grow room could be a typical 72 degrees or whatever? Are you still seeing optimal nutrient uptake at those temperature ranges?
Yeah, so the temperature has to do with the stamen, or the stomata. So even at the same temperature range, or even with the LEDs, yes, you're going to have better growth with the LEDs, especially good LEDs. But it's not going to be significantly different than if you hadn't. Well, you're going to get better with LEDs, but the temperature still should be that same leaf surface temperature. I wouldn't slack on that just because it's an LED.
So you still have to probably warm this. Okay, all right, I got it.
Yeah, again, you could run it lower, and you will get better results, but you know, it's not optimal if you're trying. Now, actually, I was talking to I forget who it was the other day. They ran a study where they ran the plants at like 105 and 95% humidity and 2,000 ppm CO2, and they were getting leaves that looked like ferns, and the plants were just growing like stupid fast, like bamboo almost. But that's not at all commercially viable at all. It's just cool for a lab experiment. You know what I mean? So. Yeah, you see that a lot of aquatic plants too. If you jack the CO2 to super high levels, it changes the morphology of the leaves. A lot of different plants do that. So, any other questions? All right, thanks a lot.
Thanks, Steve. We're going to break. There's some sushi in the back. We're going to start up again in an hour, 7:30. We're going to do basically an open Q&A. And so we'll get all the speakers that are here up on stage and just let the discussion happen. It's going to be a good time, you guys. It'll be really informative and fun. So take a good break, stretch, smoke, eat, and drink some water.
somebody asks me, I do, but I can't think of them.
All right, we're going to announce this Puffco winner real quick. I got
Why did the cheeseburger answer?